let's graph a transformation of a logarithmic function, specifically with a reflection. So we are going to graph f of x equals negative log of x minus 2 based 2. All right, so we have a couple of things going on here. We're going to have a horizontal shift, first of all, and a reflection. So we always want to focus on the parent function. So the parent function here is going to be f of x is log of x base 2. Because if you can understand the parent function, then we can say, how does everything else move? Okay, so x, y. First of all, sometimes it's a whole lot easier to think of what is the value of y and solve from there. So remember, f of x is the same as y. So let's start with 0. If I plug in 0, I get 0 equals log of x base 2. So that means 2 raised to the 0 power equals x. Well, 2 to the 0 is 1 because anything to the 0 power is 1. All right, let's do it again. Let's go 1. So 1 equals log of x base 2. So that's 2 to the first equals x. That's 2. Well, this is fun. Let's go negative 1. Let's make things exciting and go with a negative number. So now I have 2 to the negative first, which is 1/2. And let's go ahead and do 2 as well. So log of x base 2 gives us 2 raised to the second. So that's 4. So now I have 4 ordered pairs that work with my parent function. Okay, so let's graph that to start. We have the 4 ordered pairs. I lost my pen. We have 1, 0. We've got 2, 1, 1/2 negative 1, and lost 4, 2. I forgot what the last one was. Okay, so this is the parent function. 1, 0, 2, 1, 1/2 negative 1, and 4, 2. I'm not going to draw the curve between them. I just want the spots, the positions. Okay, so I know this is what my parent function looks like. Okay, we'll call it the PF. Now, the horizontal shift. The horizontal shift moves everything to the right 2 units. Just everything to the right. Okay, so let's do that. If I move everything, 1, 2, 1, 2, 1, 2, 1, 2. Great. Great. So that's all we do for right now. Stop. Now, this negative basically flips, this negative flips across the x-axis, right? Because it makes, it flips the y value. It makes the y values the opposite sign. That's what it means by flipping across the x-axis. So when you think about this, every one of these, so like this point right here is 2.5 negative 1. So if I flip that across the axis, it would be 2.5 positive 1. So everything is just going to kind of flip across this here x-axis. Okay, so let's do that. I'm going to do that with a big gray dot. All right, so I'm going to start with this one, and I flip it. So instead of being at negative 1, it's going to be at positive 1. Now, you can't do anything. If you're at 0, flipping it, you're still at 0. The one at 4, 1 is now at 4, negative 1. And at 6, 2, I'm now at 6, negative 2. And just to recall before, in our parent function, we have a vertical asymptote at x equals 0. So if I move everything to the right, now my asymptote is now here. So let me get rid of my red asymptote here. Okay, so I've moved my asymptote over as well. So now when I connect my dots, this is my graph. So you can see how I did this in kind of 3 phases. I graphed the dots of my parent function. Then I graphed the dots of the horizontal shift. And then I flipped across the x-axis. And so there's kind of the piece. And then if you want, I can get rid of these ordered pairs off of here. And then you can just see my gray curve. So you can see how when I flip it, it's got a different looking curve than the traditional logarithmic function when you graph it. But that's using a reflection.